as the Euler equation. Euler equation. Okay. So what is the form of Euler equation? Any doubt with the last class? So if you look at the second order one, okay, the second order equation I'm yet to write, okay, y double dash plus p1 y dash plus p2 y equals to f of x. Okay, this is our equation. Okay. So now in this equation, if you put fx equals to 0, and we will retain all the second degree terms. So what will happen here? Then the equation, we can write it in this form. So this is one equation 1. If you remember, it's a non-homogeneous equation. Okay. So if we put fx equals to 0 and retain only up to second order terms of the equation. So the equation, you may write it like this: x squared d squared y by dx squared. Sorry, I think it's the last equation. So here are the xn, the last equation what I have given, the n where we have the nth order general equation. Okay. So there if you put fx and that dn term, I think what I have given to you in that, we have, so this one is, the equation was like this. Okay. After putting this, it is like this: xn dn plus p1, then xn minus 1, dn minus 1, dn y equals to fx. So here if we put fx equals to 0 and retain up to second order terms of equation 1, then we will have this one: x square d square y by dx square plus, I think, x dy by dx, here a constant a, plus b y equals to 0. I think this will be of this form. Okay. This a, b are constants. Okay, a and b are constants. So here, linear equations with constant coefficients. The equation 1 is known as uh, Euler equation or Cauchy equation, or sometimes also Euler-Cauchy equations. Okay. So it's also sometimes known as Euler-Cauchy equation or simply Cauchy equation. Okay. So you will see in some books it's Euler-Cauchy equation or only Cauchy equation. So we can solve this equation simply by substituting. Okay, we will do one substitution for this particular form of equation when you have x square d square y by dx square plus a x dy by dx plus b y equals to 0. If this is your form of equation, then you can solve this equation by substituting y equals to x power m. Right, this is Euler's equation. So to solve this equation, whenever you have this particular equation, we substitute y equals to x power n. Okay, this is our substitution. Okay, y equals to x power n. Now what happens? You'll look at the terms. Okay, so if this is this one, dy by dx will be m x power n minus 1, and the second order derivative d2y by dx square equals to m into m minus 1 x m minus 2. Now we substitute these values in equation 1. Okay. We substitute these values in our Euler equation. Okay. 2. 2 is the Euler equation. So we put these values in Euler equation. This one. Okay. Now what's happening? So x square, then d square y by dx square. So we can put it here m into m minus 1 into x power m minus 2. Then a x into dy by dx will be m x m minus 1. So why we are doing this? We need the auxiliary equation. That's why we are doing this. Then we have b y equals to x power m equals to 0. So you see here x power m, x power m, x power m. If you take common, we have m into m minus 1. Okay, let me write it properly. Okay, then a x power m minus 1 m plus bx power m equals to 0. So we can take x power m common, then we are left with m into m minus 1 plus m.
A for m only, man.
Which one I left? What
A
happened?
x for m. A x for m only.
A little bit clear. Okay, loud and clear, you say. Speak.
M a for a into x for m only.
This one?
Second term only x power m minus 1 you have written.
But why x power m? This is x power m minus 1.
A
Into x.
Okay. This one.
Yes, ma'am.
Okay. The second line. Fine. So here m and a is there. Then b equals to 0. So the important thing is this is our auxiliary equation now. Okay. So this is the auxiliary equation or the characteristic equation. Okay, we need the values of m so that we can have our complementary function or the solution to this equation. So what will be the solution here? So because x power m not equals to 0. Okay, so that's where we can write it. So what is the solution here you can think of for m? See, now the quadratic equation you have. What is the solution m? You can think of. Okay, so you know, let's say it's a quadratic equation. You will have the roots. Okay, so you have to find out what is the root. Okay, and you know, like if you have the distinct real roots, what will happen? If you have the repeated roots, what will happen? And if you have the complex roots, what will happen? Okay, so this you will find. Okay, so now if one option I'm saying, if m1 and m2 are roots of roots of equation 2, the characteristic equation or the auxiliary equation are different, then the solution y equals to c1 x power m plus c2 x power m2. So this is m1, this is m2. Okay, so we will have this type of thing. Okay, c1 x power m and c2 x power m. So because y equals to x power m we are considering. Okay, so this will be the solution of the form x power m here. Okay, so this is the general solution. Okay, general solution of Euler equation or Euler-Cauchy equation. General solution of Euler equation is okay. Now one example let me do. Hey, you can do it. Okay, we have already done so many problems, so try and do it. See, if you want, you can do in a normal way also, and so you can identify it's the Euler form. This form is the Euler equation, so you can try to solve this one in Euler form way. Simply by substituting y equals to x power m. Okay. So what is the solution you find out? Let's find out. Done, anyone?
c1 x square divided plus c2 y square.
Square minus
Wait. The solution you are saying y equals to
c1
c1
x square
is
plus c2 y x square.
x square
minus 2.
c2 by x.
minus. Okay. So this is the solution. I think you can get it. You substitute it. Y equals to x power m and start solving. Okay. Should I do it or you can do it? It's a simple one. Okay. You already know, right? I told you what is there for second order and first order. So the equation will be x square, I think m minus 1, then x power m minus 2. If you do the substitution, then this is x power m minus 1. So if x power m cancels, so m into m minus 1 plus m minus 4 equals to 0. So here m we are getting 2 and minus 2. So this is how the solution you are getting. Okay. General solution. So I'm not doing. Okay, we have already solved many. Okay. So for the Euler form, this is what, and the next what we have for the Euler form. So what is next? After Euler equation, we have a system of differential equations. Wait, system of differential equation. Okay, so for the system of linear equations, so till now we are discussing about the solution of a single linear differential equation. Okay, so where y is the dependent variable and x is the independent variable. In this section we consider, okay, in this particular system of linear equations, we consider solution of a system of two linear first order equations in two dependent variables y1 and y2, and one independent variable t or x, whatever you will consider. So here you will have two equations, okay, and we will restrict ourselves to the solution of constant coefficients only. Okay, till now we are actually doing the constant coefficients or the forms which we can reduce it to the constant coefficient form, like Euler equation. You look at the coefficients, these are x square, but we are reducing it to the constant coefficient form by simple substitutions. Okay, and the variation of parameter also. Okay, so here we have two linear first order equations in two dependent variables. So here we have system of two linear first order equations in two dependent variables. Y1 and Y2. And one independent variable. Okay, so here we will restrict ourselves to the solution of constant coefficient form. So for example, okay, so the first one, Okay, this is the form. Wait. So this is a simultaneous equations. Whether we will consider this one or because we have two forms. One is simultaneous. That means we have two dependent variable and one independent variable. So and one is okay. Let's try this one. Okay. So this is one example. We have y1 and y2. Okay. So you and similar examples you can consider. Okay. So two dependent variable, one independent variable. So here 3 dy1. So you can remember, like whenever you are going for the parametric equation, you also do this. So this is y1, y2, two dependent variables, dy1 dt plus dy2 by dt minus 2y1 plus 3y2. Okay, we have two dependent variable, one independent variable. Let's go, right, okay. Because if you go for two independent variable and one dependent variable, that means your z will be a function of x, y, then the partial derivatives will come. Okay, so here we will talk about this one. Okay, so here these are the examples. If you see, are two systems of linear constant coefficient first order equations. A system here. Okay, whenever it's more than, we will say two linear equations or two linear differential equations. So these two systems can respectively written in operator form. Okay. So we will write it in the operator form. Okay. Because it is the d by dt that will be d. Okay. y1, y2 will remain there. So the next thing is these two systems can respectively written in operator form. So here, the first one, 6d plus 3. Okay, if you substitute here, 6d y1 plus 5d y2 plus 3y1 plus y2 equals to 0. So if you further write it, it will be like 6d plus 3 y1 plus 5d plus 1 y2 equals to 0. Then minus 5y1 the next one will be minus 5y1 plus d plus 3 y2. So these are the two system of equations. Okay, but the first one. Okay, The second one we will write it here. These are the non-homogeneous forms. Here I think e power t. E power t. So here we will write it here. This is 3d plus 2y1. Okay. So 3d plus 2y1 plus y2 equals to e power minus t. And here this is y1 minus 2. So d minus 2 y1 and plus d minus 3 plus 3. So this is how you will write it in operator form. Okay. So now we will come to the how we will go for the solutions. Okay, d equals to d by dt for this case when you have system of linear equations. Okay, so d equals to d by dt. Now what we will do in the solution? So the solution here. So we will obtain the solution by eliminating one of the variables. Okay, we will try to eliminate one variable, then we will solve the resulting linear second order equations for the second variable. Got it? So sometimes the elimination of one of the variables may also produce a first order equation for the second variable. Okay, so let's see how we will do this one. Okay, how we will eliminate this one. Okay, let me do one example. Okay. Let me solve this one. Like we do in the normal system of equations. Okay, one of the method is we keep on eliminating the variables. Okay, if you have two variables, we will try to eliminate one variable and then solve. So let's look at this one. Okay, find the solution of the system of equations So dy1 by dt plus 2 dy2 by dt minus 2y1 minus y2 equals to e power 2t. Okay, so we will try to eliminate one of the dependent variables directly. So here we will differentiate. Okay, let's make it this is equation 1. It's in equation 2. So here we will differentiate equation 2. So with respect to t, so what we will be getting, you see, the second order equations plus y1 dash minus 2y2 dash equals to 0. Okay, so here dash means the first order derivatives. Okay, now again we will substitute y1 dash from the first equation. This is y1 dash, so you substitute this one equals to this much, okay, in the first equation. From equation 2. Okay, what we get here, you see. Okay, so y2 double y1 dash, in place of y1 dash we will substitute minus 2 y2 dash plus 2y1. Okay, let's open the bracket. A minus sign is there, so we will take care of that. Plus 2y1 plus y2 plus e power 2t. Okay, so this is what we have substituted. Okay, then minus 2y2 dust equals to 0. So now we will put here, we have y2 double dust minus 2 y2 dust. Okay, these are the derivative terms. 2y2 dust, 2y2 dust, we have 4y2 dust. Okay. Okay. Plus y2 you see we have one y1 term. So if you look at here and if you substitute this one, we have only y2 term left here. So now substitute y1 from equation 2. Okay. So you see now what you are getting, y2 double dust minus 4y2 dust, so plus 2. Now y1, what will be for y1? It is y2 dust minus 2y2. Minus y2 dust plus 2y2. Minus y2 dust plus 2y2, so 2 into 2, 4. Okay, so then finally we have plus y2 equals to minus e power t. Is it right? Just look at the substitution. So now if you write a little simplification, we have, this is y1 equals to minus y2 dust plus 2y2. Minus y2 dust plus 2y2. So there is 2 also, right? So it will be 6y2 dust plus 5y2 equals to minus e power 2t. So now we are able to reduce this equation. Okay, the first thing is we differentiate the second equation, because second equation is the easy equation. You see this side is 0. Okay, that's why we differentiate the second equation with respect to t. And there we have substituted the values of y1 dust and y1. Okay. So then we are getting the equation which is the second order equation with respect to the variable y2. Okay, so now we can, the normal equation form you can proceed. Okay, so it is d square minus 6d plus 5 y2 equals to e power minus 2t. Okay. So now we will find the general solution form. Okay. So first one we will go for the auxiliary equation, and this auxiliary equation is m square minus 6m plus 5 equals to 0. So the solution of m will be what? What will be the solution? There is the complex solutions. 1 and 5. Minus 6m, so you can put it minus here 5 into 1. Okay, so m equals to 1 and 5. Okay, so the general solution, the y complementary function. Okay, so it will be a or the c1 e power x plus b e power 5x. A, B constants like c1, c2. So this is the complementary function. Now we will look at the particular integral. Okay, so here 1 by d square minus 6d plus 5 e power minus 2. Okay.
No, minus C port 2D now.
Yeah, what I missed? Minus sign, yes, thank you. Minus sign is missed. So here we'll put minus sign. Okay.
Minus 4 2T.
Oh, what you said? Minus?
Minus C port 2T.
Which one? I couldn't understand. Minus e power?
Ma'am, it is not minus 2t, it's only 2t.
Oh, okay. And the okay, here in the exponent form. This is only 2. Yes. Okay, thank you. So now we will find the solution. So what will be the solution here? If you put, normally first we will put f of a. If it's not getting 0, you see a is 2. So this will be 2 square 4 minus 6 into 2, 12. So you see this is 4 minus 12 plus 5. So how much you are getting in the denominator? Minus 4 plus 5, 9. So minus 3 is coming. Okay. So here this much is minus 3. So here we can write it as 1 by minus 3 in, minus e power 2t. So it is e power 2t by 3. Are you getting this much? Just look at the calculation. Then the general solution y will be the yc plus yp. If you want, you can write it. A e power. Okay, I have written x here. This is the variable t. I have written. See, actually, why I have written in some books, you will find instead of y1, y2, they are considering x and y as the dependent variable and t as the independent variable. So it's that's fine. It's up to you. Okay, whichever you will consider the independent variable or dependent variable. So now here this will be a e power t plus b e power 5t plus e power 2t by 3. So are you getting this solution?
Yes, ma'am.
So this much is enough. Okay. So we have the solution of y1. Sorry, y2. This is the solution for y2. Isn't it? You see? The solution for y2. So what will be the solution for y1 that you have to find? So this is the solution for y2. We have to find the solution for y1 also. y1, you see, the easiest equation is this one. The second equation for y1. So y1 will be equals to 2y2 minus d by dt of y2. I think this is what it was written. Second order equation. No, the first order. I'm sorry, you can't see the upper part. Okay, this is the second equation. From that, we are getting this one. Now we will substitute the y2 value here. Okay, so 2y2 a e power t plus b e power 5t plus e power 2t by 3 minus the first order derivative. So a e power t will remain a e power t. Let's make it this way. It's plus. You also do the calculation because I'm making sometimes there. So you just take the calculation. 5b e power 5t. Okay, and this will be 2 by 3 plus 2 by 3 e power 2t. So this is, so what you are getting, 2a e and minus a. So will be a. This is 2b and this is 5b. So minus 3b. And then this is 2 by 3 e power 2t, 2 by 3. So this gets cancelled. So this is your solution for y1. Okay, so this is how we are getting our solution. It's an easier one. Okay, it's a differential equation, but how we are getting is we are trying to eliminate one variable and we solve for the other one. Whatever value we are getting, then again we substitute in the equation and find it. Okay, like solving the system of linear equations. This is also the same process. Okay, so you can use different whatever methods you know. Okay. So one example we did, another you solve. Solve the system of equations. Of equations. So you solve this two equation. It's again given in terms of the operator form also. So you try. See, there is one thing also you can see here. This is 2d minus 4. If you take common 2, this will be d minus 2 y1. So if you multiply here 2, you can simply cut out this y1 variable. Isn't it? That way also you can follow. If you put it this as equation 1 and this as equation 2 and you multiply equation 2 by 2, then this first variable is, you can cut off. That is also one of the, you don't have to go for the derivative. Got it? So that way also you can find. See, this is the equation. Okay. Now this equation multiply with 2. So see, if you multiply it by 2, see this first term you can cancel out. Right? 2. Now this, what we are left with? 3d plus 2. So if you don't want to write this one, okay. 2. So here you can say, this is what we are getting. So here 3d plus 5. So you add it. 3d plus 2d is 5d. 5 plus 2 is 7. y2 equals to 3t plus 2t is 5t plus 2. See, this one is much easier. Got it? This is how also you can do the cancellation. So you try to write down in operator form and see what you can do. 5d plus 7. So just look whether I have done the right calculation or it's up to you. You can add or you can subtract. We are subtracting. That's why it's getting division. Sorry, I made mistake. We're subtracting, right? That's why actually we are able to cancel out these terms. Okay, I'm so sorry. This is minus. This is minus. This is also minus. So 3d minus 2d is d. Then 5 minus 2 is 3. Y2, 3t minus 2t is t plus 2. Okay, so it's easier, right? Now, if you look at the auxiliary equation, it's the easier one, m minus this one, the first one. You see this one. If it is of this form, pxy qx form, then this is. If you take this one, qx into e power px form, okay. Okay, so qx, what is first we write qx? Or you can put also this one. T. If you multiply, you can also multiply with this one. Then it will be e power minus 5t. A 2a e power minus 5t plus 1 by 9. So e power minus 2t y1 into a e power minus 5t. See here we have multiplied e power minus 2t dt and b is the constant. So you can integrate now. Minus 2 by 5. Then e power minus 2t by minus 2. The next term will be 1 by 2. 6 e power minus 2t by minus 2 plus the constant of integration. Okay. So the y1 is, again this will come to this side, then e plus 2t. So here minus 2 by 5. Let's write one more. B will be there. So b e power 2t minus 2 by 5 a e power 10 minus 1 by 8 6t minus 5. Because here you simplify this one and you will be getting this to make it 1 by 9. Okay, 1 by it will be 1 by 8 6t and here it is minus 4 e power minus 2t. Okay, and here it is 6. So here what we will be getting here? It is 3 actually, 1 by 2 is there. So it is 3. So this 3 plus 4, we are making some 5 is coming, and e power minus 2t and e power minus 2t gets cancelled. So this is what we have. Look at the calculation. Okay. Is it right or any mistake I did? 1 by 18 you take to this side, minus 2 is there, minus 2 minus 2. Okay, then we have 60 e power minus t. So if you multiply it, we have 60. Then it is minus 8 e power minus 2t. And here 2 and 6 you have 3. So minus 8 plus 3 will be minus 5. And e power minus 2t, and this it's cancelled. So this is what y1 is, and this is what y2 is. Okay. Have I cleared this one? A system of linear equations you will solve like this one. Okay. So you can go for the equation. Okay, let me give you the giant angle exercise. Exercises you do. Okay. So once you are so you have I've written their exercises. I think it's 5.7. Okay. Any doubt with this one? It's already time. So are you coming today? Today we will take one more class, 3 to 4. Can you hear me? One more today class if you take now, at least almost same, because almost all the all sections this module 3 is complete. Can you hear me? Okay, I will talk to your CR. Okay, so you can leave now. Let me take the attendance.
Thank you, ma'am.
Thank you.
Thank you, ma'am.